Okay, hello everyone. So I thought I'd make a video about motion graphs. So this will cover how to interpret certain situations. Say you're given a description of the object's motion and you have to interpret them by position time, velocity time, and acceleration time graph. Okay, so let's start with the first case. There are 6 cases in total. Case 1. Your direction is positive, meaning it's going up, it's going to the right, it's going east, it's going north, or it's simply in a positive direction. Okay? And your acceleration is 0, meaning your object is moving at a constant speed. Okay? So how would this look like in a position time graph? So first, let's pick a different color. That's actually not very visible, so I'll pick another color. Okay? So in a position time graph, P versus T, if you're moving at a constant speed, that means that speed is the slope of the line of a position time graph, remember? So that's rise over run. So that means that every run, you will rise the same amount. Okay, so this one is equal. So all you have to do when you connect the dots is find that for a position time graph, you'll get a linear path going up. In a velocity time graph, meanwhile, this kind of situation, let me just label 0 again. This kind of situation, when you have a constant speed, that means your velocity does not change. So it means it's just going to be a flat line. But remember that your direction is 0. Or rather, your direction is positive. So that means it's going to be a flat line above 0. What about acceleration time graph? Well, for acceleration time graph, let's get that graph going. Or let's put the 0 a bit to the middle. Okay, acceleration versus time. So for acceleration time graph, when you have a constant speed, this means your acceleration is actually 0. So that means your acceleration time graph is actually completely at 0. That's it. It's just a straight line. Pag acceleration time graph, it's always going to be a straight line. That's just flat, not slanted, flat. Okay? So that's for case 1. What about case 2? Case 2 comes when your direction is still positive, meaning it's going up, it's going to the right, it's going east, it's going north, positive direction. But your acceleration will be positive, meaning that your speed is increasing. So how does that look like? Let's use a different color. So in this case, for position time graph, every rise that you make or every run that you make, it goes up and up. So bigger jump, much bigger jump, much bigger jump. And when you connect the dots, it will be parabolic in shape, like that. Position versus time. How about for a velocity time graph? For a velocity time graph, your speed is increasing. It's going up as you go on. But remember that your direction is positive, okay? So that means for a velocity time graph, it's a simple straight line, okay? A straight line going up, moving away from 0. How about for acceleration time graph? An acceleration time graph, remember what I taught you about how to get it from these two signs? Positive times positive gives you positive. So that means that your acceleration time graph would look like this. Remember, it's just a straight line. Okay? So it's a straight line in the positive or above 0. Case 3. For case 3, your direction this time is still positive, but your acceleration is negative. This means that your speed is decreasing. So what would happen if your speed is decreasing? Well, for a position time graph, it means that every rise or every run, you'll go up less and less. So less, less, less. And when you connect the dots, it's going to be, again, like a parabola, but pointing downwards. How about for velocity time graph? For velocity against time, you are in a positive direction. So that means you will start above 0. Okay? But you're decreasing in speed. So that means you're moving down towards 0. You're decelerating. So that's how it looks like. How about for acceleration time? Well, for acceleration time, again, it's just a straight line, but you're already given an acceleration that is negative. And positive times negative gives you a negative. So that means acceleration will be firmly below 0. Okay? So those are the cases wherein they are in a positive direction. But how about if they're moving in a negative direction? How would they look like? So let's start. Same thing, but direction meaning negative. Acceleration is 0. So that means you're moving at a constant speed. Okay? So how would this look like? Well, using a different color, position versus time, and that's 0. So if you're moving in a negative direction at a constant speed, it means that for every run, you will rise going down in the same amount. Okay? And when you connect the dots, it will simply be a straight line moving away from 0. How about for velocity time graph? For your velocity time graph, velocity against time, okay, it will always be a straight line if it's a constant speed because your velocity doesn't change. But because your direction is negative, that means it's going to be below 0. That's it. And for acceleration time graph, negative times 0 gives you 0. So simply a straight line at a equals 0. Excuse me. A equals 0. Okay? So that's case 4. Case 5. Here, your direction is negative, but your acceleration is positive. That means that if you are negative in direction but positive in acceleration, you're actually negative. That means you are decreasing speed. Might sound confusing at first, but again, negative direction, positive acceleration, multiply the two gives you a negative result, decreasing speed. So how does that look like? Well, we can, again, use a different color. Sorry. Maybe pink would do. That's better. Position time graph. So what would happen if you're decreasing your speed? So every rise, again, it starts out way big, and then the next one will be much smaller. Next one will be minuscule. Connect the dots, looks something like that. This again is 0. For velocity time graph, you are decreasing your speed and you start in the negative direction. If you remember, velocity time graph always begins with the direction, so you start at the negative. But if you're decreasing speed, that means you're approaching 0, going that way. And this makes sense because this has a positive slope. And your acceleration, which is the slope of the line of a velocity time graph, is positive. Okay? How about for acceleration versus time? Well, we've already determined that positive times negative is negative. So it will just be a straight line below 0. Okay? So that's your case 5. And the final case, case 6. Your direction again is negative, but your acceleration is negative. This gives a positive if you multiply, and that means you are increasing your speed. increasing your speed but in the negative direction. So how does that look like? Let's use gray. For position versus time, actually that's pretty long. I'm going to shorten that slightly to give more space. Position time, this is 0. So that means that every rise or every run, it gets bigger and bigger. And if you plot the points, it looks something like that. Okay? For velocity time graph, this is 0. If it's increasing in speed but in the negative direction, let's start with direction. Direction is negative, so you will start in, you know that you're going towards the negative. But if you're increasing in speed, you're moving away from 0. Moving away. So that's how your velocity time graph would look like. And finally, acceleration versus time is just a straight line. Negative times negative is positive, so it's just a straight line above 0. And this is all you need to know about the motion graphs. It might be confusing to memorize, so I suggest you try to visualize it using rise over run. So thank you for watching. I hope this video was very helpful to you, and I look forward to teaching you about other topics. Take care.